Hi everyone, so I'm going to continue with trig identities. So this is trig identities part 2. So I showed you in the previous video 3 examples of how we use trig identities to simplify. Okay, so right now your responsibility is just to simplify. Next year in calculus, you'll simplify while doing derivatives or limits. Right now, you're just learning how to simplify. Just like when you learned how to simplify algebra, you learned it first and then you applied it after. Okay, so right now we're just going over how to simplify or verify. So in terms of a strategy, I'm going to keep it very simple. What's helpful here? Well, first of all, you only work with one side. And I think we saw that when we did some proofs with logs and exponents. Okay, so you only work with one side. Now, which side do you pick? So which side? It's not always the left or the right. So what I say is you have to choose the more complicated side. Okay, so just to clarify, sine and cosine are considered the least. No, it's not how we spell least. The least complicated. And anything with an addition, if there's an addition, it's more complicated. Okay, so for example, if one side had sine and cos and one side had an addition with sine and cos, then you would pick the side with the addition. If one side had the secant and tan and the other side had tan plus something, right? So the addition is more complicated. Okay, and if they both look complicated and they both have additions, then it doesn't matter which side you pick. You try as much as possible to keep sine and cosine. So we don't want to convert sine to 1 over cosecant. You just be making it more complicated. Or change everything else. Change other identities to sine and cosine. So just to give you an example quickly. Cotan is also 1 over 10. But another way of writing cotan is cosine over sine. So this one would be better because it has sine and cosine. Sine and cosine simplify into the basic Pythagorean identity. So that's the unit, I'll call it a unit, that you're looking for. Be ready to find a common denominator. That comes up a lot. Okay, so if you have an addition, be ready to find a common denominator, and sometimes we will have to factor. Okay, so those are the steps. So I'll do a few more. Remember, it's page 95 that has all the identities that we're going to be using. So if we're going to continue, this would be example 4. This would be your 4th trig identity. Okay, so this identity says that this subtraction, I said addition, but I meant to say addition or subtraction. So we have this side and we have this side. Okay, now sine and cosine, yes, are considered less complicated, but the fact that there's an addition makes the left side more complicated than the right side. Because it's easier to merge 2 terms into one than try to convert tan into a subtraction. Okay, so there's not much to do besides find the common denominator. And the common denominator is just having one of each term. So it'll be cos times 1 plus sine. Okay, so whatever I introduce on the bottom, I introduce on the top. And on this side, I have to introduce cosine. Okay, so a common denominator is basically just, so imagine if this was 3 and this was 7, common denominator 3 times 7, 21. So because there's an unknown, we can't simplify any further, but we just put them as factors. So now we simplify. So what do we have at the top here? 1 times 1 is 1. 1 plus sign is just sign. I will not multiply out the denominator. Okay, don't do it unless you really have to. Cos times cos is cosine squared. Okay, and I'll just put them in the same order because it's a common denominator. Okay, so what do we have? We have a common denominator, good. So let's do that. At the top, we have 1 plus sine minus cosine. So there's a little trick here. 1 plus sine is nothing. Sine minus cosine is nothing. But if you rearrange the terms, okay, so if you're thinking, I would have never thought of doing that, that's fine. But that's why you practice. Okay, you do as many as you can so that you've seen a lot of possible steps that come up. And the reason I'm doing this is because if you look on page 95, 1 minus cosine is actually sine squared. Okay, and I'm just going to cross it out. We don't need this here. We're going to factor. Sine divided by sine is sine. Sine divided by itself is 1. Okay, we're actually almost done. Should be writing equals right side equals right side equals right side. And there we are. These terms are the same. So sine, I know I have 1 plus sine there, but it's the same, it's addition, so it's fine. It doesn't matter if you rearrange it. And sine divided by cosine is 10, and 10 is equal to 10. Okay, so that's example 4. So they're getting a little bit more complicated. You're lucky in the sense that you can pause, you can rewatch, you can go watch other videos. Okay, we're going to keep going. So let's do example 5. Let us do cosine. Okay, sometimes it's x, sometimes it's theta, minus sine plus cosine over 1 plus sine is equal to 2 secant x. Okay, again, this is the more complicated side. Yes, it has sine and cosine, but there's an addition. Common denominator. As soon as you see separate terms, that's what you should be thinking. Okay, so I'm gonna rewrite, I'm just preparing everything so that I can introduce the common denominator. And common denominator, remember, you're introducing the right term on the left and vice versa. Okay, so what do we have here? We have cosine of x. Okay, so earlier I said to leave it in factored form, but not when you have to add. Okay, so I'm going to simplify here. Cosine, I'm going to distribute is what I mean, times cosine sine plus cosine of x minus cosine, sine, all over my denominator. So my denominator, I will leave like this for now. Okay, so what do we have at the top? The top, we can cancel out this and this. So we have 2 cosine x over, now I will simplify. This is difference of squares, 1 minus sine squared. Okay, so I'm gonna equals right side, equals right side. I'm gonna keep going. Hopefully you recognized it. The bottom is actually cosine squared. And now if we divide, we have 2 over cosine. But really, it's like saying 2 times 1 over cosine. And that is equal to 2 secant x. Okay, so let's just look over the mean steps here. We're common denominator. You have to simplify the top to merge. The bottom, you don't have to simplify right away. What was my clue that I should have simplified here? Well, I have cosine here, and I have sine, so I should probably simplify. Okay, and we'll do one more for now. Then we'll see what questions you have on Wednesday. Don't forget the workbook. So here we have sine squared minus cosine squared, sine, cosine, tan minus cotan. Okay, so they're both fairly complicated, but the right side seems to be obviously more complicated than the left. So what can we do here? So we'll leave sine, we'll leave cosine. How about we write tan as sine over cosine, and we write cotan as cosine over sine. Okay? So more complicated in the sense that there's more terms, but I think the steps will be familiar. Common denominator. Okay, you can't merge unless you have a common denominator. Common denominator, cosine, sine. Okay, so basically what am I doing here? I'm rewriting it, but then I want to introduce. So at the bottom, I need another sine. So sine at the top. On the other side, I need a cosine, cosine at the top. Okay, so what does that leave us? Sine squared over cosine sine minus cosine squared over cosine sine. We're going to merge our terms. So sine, cosine times, right, cos sine, sine squared minus cosine squared. And we're basically done because look at our left side. So that's what we were looking for. So we have it right here in the numerator, and these terms cancel. So we're left with the left side equal to the right side. Okay, and we'll end it with that.